Good evening, Lamai. Let's start our first extra class. Right. Listen, Nick, for 2025 batch, we have arranged this extra class to discuss the tutorial. But as this is the first day, I would like to explain some theory part. And the class is divided in two sections. The first half is used for units and dimensions lesson. The next half is used for the mechanics lesson. Right. So let me explain few theory before I directly go to the questions. Right. Look at what here. So what is a dimension? What is the dimension? Dimension is a symbol and it represents a given physical quantity. Right. For example, length is the physical quantity. Length is a physical quantity. It is represented by the symbol capital L. English letters are symbols, right? And the second example that we know, mass is a physical quantity. It is represented by the letter capital M. I'm not going to teach you theory. I'm just going to revise the theory and I'm going to discuss some questions. That's how it works, right? And dimensions of time. Time is a physical quantity. The dimension is capital T. So you have already learned these things, right? And what is a physical quantity? And during the class, I allow you to unmute the mic and answer my questions, right? It means I'm not the only person talking in this class. Students should answer my questions whenever I ask. So physical quantity is something that can be measured directly or indirectly. We can measure length, therefore length is a physical quantity. We can measure mass, therefore mass is a physical quantity. We can measure time, therefore time is a physical quantity, right? Then under that we have learned something so-called derived physical quantities. Derived physical quantities. The first derived physical quantity that we have learned is velocity. Velocity. Velocity is defined by displacement time taken. Displacement divided by time taken. Displacement is the length. We have learned what a displacement is under mechanics lesson. So displacement is the shortest distance. Distance is the length. So therefore, displacement has the same dimension as length, capital L. And time, dimension of time is capital T. So if the T comes up with the minus sign, so the dimensions of velocity will be L T to power minus 1. Normally, we don't say T to power minus 1. Simply we say T minus 1, right? The second example that we have learned under units and dimensions lesson is under the derived physical quantities. We have learned acceleration. 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 So acceleration is, we defined acceleration as change in velocity divided by time taken. Simply change in velocity divided by time taken. Divided by time taken. So change or whatever, velocity is a velocity. Therefore, change in velocity and velocity both have the same dimensions. Dimensions of velocity we have found it as Lt to power minus 1. Therefore, change in velocity also have the same dimensions as Lt to power minus 1. Lt minus 1. Divide by time is T. This T can be taken up with the minus sign. So then it will be Lt minus 1 into T. So another T minus 1. This T comes up with a minus power. T minus 1 into T minus 1 is T minus 2. So then this is L T to power minus 2. So dimensions of acceleration is L T to power minus 2. I think all of you have learned these things. The third example that we have learned is force. So how to find the dimensions of force there? According to Newton's second law of motion, you have learned this in your O levels. Force is equal to ma, mass into acceleration. F equals ma. Dimensions of mass is capital M. Dimensions of acceleration we have already found Lt to power minus 2. So mLt minus 2 is the dimensions of force. I'm not going to write everything. I'm going to write few of things. Just wait and see. So what are the dimensions here? Dimensions are symbols. they represent physical quantities, right? The first physical dimension that we have found is velocity. Dimensions of velocity is Lt minus 1. Dimensions of acceleration Lt minus 2. Dimension of force is MLT minus 2. Then do you remember that we have learned area? The area of a rectangle is length into equal to dimensions of width. Length is a length. Actually, width is also a length. Therefore, its dimension is also capital L. Capital L into capital L means L square. Right? So I discussed only the things which will be needed for today's class. Right? The fifth one that we have discussed is pressure. What is pressure here? What is pressure? What is the equation that we use to find pressure? Somebody unmute the mic and tell me what is the equation that we use to find pressure? Somebody please unmute the mic and tell me.
Force of area.
Very good, excellent. Dimensions of equations of pressure is force over area. Force over area. Very good. Right? So dimensions of pressure equals dimensions of force divided by dimensions of area. Dimensions of force divided by dimensions of area. Dimensions of force, we have already found MLT minus 2. MLT minus 2. Divided by area is L square. L square means L into L. L square means L into L. So one of the L terms can be cancelled out. So the remaining terms will be MT minus 2 divided by L. MT minus 2 divided by L. This L can be taken up with the minus sign. So it will be ML minus 1 T minus 2. So what is the dimensions of pressure here? ML minus 1 T minus 2. Right. Let me write one more example. Right. 1, 2, 3, 4, 5, 6th one. Let me take it as volume. What is the volume of a cube here? You may know it. Number 6. Let's say you want to find the volume of a box. So what is the equation? Somebody unmute the mic and tell me. What is the volume of a box?
Length into width into height.
Very good. Length into width into height. Length into width into height. Length into width into height. I'll try to manage the available space, right? So then length is a length, width is also a length, height is also a length. L into L into L. So it means L to power 3. So I would like, if please take a separate book for this class, please write tutorial discussion class and write them all as a revision. And after you have written this theory, we'll start question discussion. Okay, dear? Don't be lazy. Take a separate book or some separate papers and write them all that I have written on the board. Start here. Everybody please quick. And once you have written, send me a message saying done. So then I know that you have written. Quick. Right, I think time is enough. Let me write one more example. Right. The last example that I'm going to write is, I think everybody is able to hear me properly, right? Seventh one, density. Right, somebody unmute the mic and tell me what is the equation that we use to find density of a material. Somebody. You have to talk to me. Somebody unmute the mic and tell me the equation that we use to find density. Nobody knows. Are you sure? Okay, okay. Sorry, I forgot to. Now you can unmute the mic. Yes. What is the equation here?
Mass over volume. Mass over volume.
Very good, very good. I forgot to allow you to unmute the mic. Right. Okay. So density equals mass over volume. Mass over volume. Mass is capital M. Volume is L to power 3. Volume is L to power 3. So L to power 3 comes up with the minus sign. So you get ml minus 3 as the dimensions of density. So this is the last one that I'm going to give. After that, let's discuss some questions. Complete here. Write this one also. Right. Is there anybody who wants any more time? If anybody wants any more time to write these things, please raise your hand up there. Or send me a message saying that you want time to write these things. Is there anybody who wants any more time to write the things? Okay, no, right. So let's write our first example. Example number 1. Please write example number 1. The following equation gives, please write example number 1. Example number 1. The following equation gives total mechanical energy. The following equation gives the total mechanical energy. The following equation gives total mechanical energy of an unit volume of a fluid flow. The following equation gives the total mechanical energy of a unit volume of a fluid flow. Of a unit volume of a fluid flow. Show that the equation is dimensionally correct. 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 Look at board here. We know that liquids, a fluid is a common term for gases and liquids. A fluid is a common term which is used for gases and liquids. Let's think about a liquid which flows through a tube like this. A liquid flows through a tube like this, right? Look at board. Look at board. Right. Then a unit volume of a fluid, what does it mean here? A fluid will be everywhere. The tube will be completely filled with the fluid. What's the meaning of unit volume? Can somebody tell me what a unit volume is in simple words? Somebody? It's not such a big case. A unit volume means 1 cubic meter. 1 cubic meter. Any unit, 1. That's the meaning of a unit volume, right? So let me consider a unit volume of the fluid here. So this is a unit volume. A unit volume means 1 cubic meter according to the system of units that we use. According to SI unit system, SI units, a unit volume means 1 cubic meter. Let's say this 1 cubic meter of liquid, let's say this is the ground. Let's say this is the ground, right? This is the ground, right? So let's say this unit volume of liquid is at a height of h meter from the ground. This unit volume of the fluid is at a height of h meter from the ground. And the velocity of the fluid, velocity of this liquid, let me take it as V meter per second. What's the velocity of the liquid, Lamai? V meter per second, right? And liquids, gases, they have pressures. So this is the unit volume of the fluid. It is at a height of h meter from the ground. And the liquid flows with the velocity of V meter per second. And the other important quantity is the pressure. The pressure acting on this unit volume of the fluid, let's say P Pascal. P Pascal. Then in a mechanics lesson, we can obtain this equation. This is a correct equation, but we are going to prove that this equation is dimensionally correct. The equation is P plus half rho V square plus rho GH equals a constant, right? Rho is the density of the liquid. G is gravitation acceleration. This H is here. P is the pressure. Draw the figure, write the equation, try to prove yourself that equation is dimensionally correct. After you have proved that equation is dimensionally correct, take a photo and send to my WhatsApp. I'll check your answers personally. I'll give you 4 minutes for the question. Try it. Everybody please try and send your answers to my WhatsApp. Right. I think time is enough. Time is enough. Look at what here. So if it is asked you to prove an equation is correct, dimensionally correct, you have to prove that all the three terms have the same dimensions. Then only you can add. For example, can we add something like this here? 5 plus 2 plus 3. What is the answer? 5 plus 2, 7. 7 plus 3 is 10. That's correct. But if I write the equation like this, 5 kilogram plus 2 hour plus 3 kilometer, is this meaningful or meaningless? Somebody unmute the mic and tell me whether this equation is meaningful or meaningless.
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 Meaningless? Yes, very good. I appreciate when students talk to me. So this is a completely meaningless equation. For an equation to be meaningful, all the terms should have like 5 kilogram, 2 kilogram, 3 kilogram. Then the mass answer is 10 kilogram. So like that, all the terms should have the same units. Not only the units, dimensions should also be the same. Not only the units, dimensions should also be the same. So therefore, if this equation is correct, dimension of the term P, dimension of the term half rho square, and dimension of the term rho gh should be the same. And their units should also be the same. So here, we only consider the dimensions. Look at what it is. So it means when a question is given in the exam, if it is asked you to prove that equation is dimensionally correct, the thing that you want to do is prove that all the three terms have the same dimensions. Right? Look at what it is. Let me consider pressure. P is a pressure. P is a pressure. Therefore, the dimensions is we have found force over area ml minus 1 T minus 2. So this is what you write first. Okay, dear? Dimensions P is the pressure. Dimensions of pressure is ml minus 1 T minus 2. Okay, dear? Who has written like this? Please raise your hand up in Zoom chat, dear. Who has written like this? Lamai? Very good, excellent, very good. Right. Then let's do the same thing to the term half rho v square. Half is a number, no dimensions. Rho is density, we know the dimensions of density. V is the velocity, and we should get the square. To say no dimensions, do we write 0? No. In units and dimension lesson, we don't write 0. To say that numbers, half is a number, numbers do not have dimensions, only the physical quantities have dimensions. Only the physical quantities have dimensions. So half is a number, therefore half does not have dimensions. To say that half does not have dimensions, we write number 1. Rho is a density, dimensions of density ml minus 3. We have already found it. Velocity, dimensions of velocity lt minus 1, but here v to power 2, v square, right? So therefore you should get lt to power minus 1 square. So what are the remaining terms? What are the other terms here? ml to power minus 3, when you remove the brackets, l square t minus 1 to power 2, t minus 2. L to power minus 3, L to power plus 2 means M, L minus 1, T minus 2. M, L minus 1, T minus 2. Okay, dear? So that's how we found the dimensions of half rho v square. And who got this answer? So, please raise your hand up in the Zoom chat, dear. Who got this? Very good, very good. Nice, excellent, super. So now, others please quickly write here. Other students please quickly write this. So this question has given us an equation. P plus half rho V square plus rho GH equals a constant. These three terms related to a flow of a liquid as shown in this figure. The question asks us to prove that this equation is dimensionally correct. To prove the equation is dimensionally correct, we find the dimensions of the three terms separately. What are the three terms here? P, half rho V square and rho GH. Already we have found the dimensions of two terms. Now you want to find the dimensions of the third term, rho GH. Right here. Right, dimensions of rho GH. Let's try to find it here. Dimensions of rho GH. Rho is a density. G is gravitation acceleration. Whether it is gravitation or whatever, acceleration is acceleration. And H is H. So dimensions of rho, density is ml minus 3. Acceleration, do you remember? Dimensions of acceleration, LT minus 2. And dimensions of height is the length, so it is L. Now you see this, M, L minus 3 into L into L, L into L square into L to power minus 3, L to power plus 2 into L to power minus 3, M, L minus 1, T minus 2. And who got this answer? Please raise your hand up in Zoom chat, Lamai. Very good. Nice. So it means you have understood the lesson. Very good. Happy. Good. Right. Finally, you see dimensions of pressure ml minus 1 t minus 2. Dimensions of half rho v square ml minus 1 t minus 2. Dimensions of rho gh ml minus 1 t minus 2. It means all the three terms have the same dimensions. Therefore, the equation is dimensionally correct. Equation is dimensionally correct. So we should write one more step to earn full marks. We should write one more step to earn full marks. Look at board team. Look at board. We should write like this. We should write like this. Dimensions of P equals dimensions of half rho v square equals dimensions of rho gh. All the terms have the dimensions of ml minus 1 t minus 2. M L minus 1 t minus 2. ml minus 1 t minus 2. So finally we can write therefore the equation is dimensionally correct. Equation is dimensionally correct. So you should write this sentence, then only full marks given. Please write this also. Quick. If anybody has a doubt, please send a message to the Zoom chat. If you have any doubt, any problem, send me a message to the Zoom chat directly so I can help you. I can allow you to unmute the mic and talk, but that will be difficult because many students, when a lot of students try to unmute the mic at the same time, I will not hear anyone properly. So the best thing, whenever you have a doubt, send a doubt as a message to the Zoom chat, right? Right, now shall we try for another example? Let's try another example. Right. Please write. Please write. It is given in an equation. It is given in the equation. It is given in the equation that example that work done by an external force. Work done by an external force is given in an equation that work done by an external force is equal to the increase in kinetic energy. It is given in an equation that work done by a force is equal to the increase in kinetic energy. Increase in kinetic energy. Full stop. Show that the above equation is dimensionally correct. Show that the above equation is, show that the equation is dimensionally correct. Show that the equation is dimensionally correct. So what is the equation here? What is the equation? Work done equals increase in kinetic energy. Increase in kinetic energy. So you want to prove this, you want to prove that this equation is dimensionally correct. Try to prove this equation dimensionally correct and please take a photo of your answer and send to my WhatsApp. I will definitely check one by one personally, right? So please write this equation and try to prove that this equation is dimensionally correct. Try here. Everybody please try. I'll repeat the question. It is given that work done by an external force, it is given that work done by an external force is equal to the increase in kinetic energy. It is given that work done by an external force is equal to the increase in kinetic energy. Show that or prove that the equation is dimensionally correct. Prove that, prove or show that the equation is dimensionally correct. Right here. Somebody please type the question and send to me. Send to the Zoom chat here. Somebody please type the question and send to the Zoom chat because some student face a difficulty to write the question. Leave some space to write the question and try to prove this equation. I have written the equation on board. Work done equals increase in kinetic energy. Try to prove it. And at the same time, somebody please type the question and send to the Zoom chat. It's a very simple thing. You want to prove that this equation is dimensionally correct. Work done equals increase in kinetic energy. You want to prove that equation is dimensionally correct. That's it. Right here. Right. First, what is work done here? Work done is force into displacement. So first of all, let's find the dimensions of work done. First of all, let's find the dimensions of work done. Work done is force into displacement. Force into displacement. Work done is force into displacement. Force into displacement. Dimensions of force. Just now we have found. I think I have written somewhere here. Dimensions of force MLT minus 2. Displacement. Dimensions of displacement, it's a length L. So then L into L is L square. Therefore, dimensions of work done ML square T minus 2. ML square T minus 2. Who got this answer? Please raise your hand up in the Zoom chat. I would like to see. Please raise your hand up if you have obtained this. Excellent, excellent. Super, very good. Others, please quickly write. Very good. Right. Then we want to prove that dimensions of increase in kinetic energy is also the same. Dimensions of increase in kinetic energy is also the same, right? So let me write like this. Increase in kinetic energy. Increase or decrease kinetic energy is always half mv square. Kinetic energy is always half mv square. Whether we are going to find increase in kinetic energy or decrease in kinetic energy, it will be the same. So increase in kinetic energy is dimensions of increase in kinetic energy should be equal to the dimensions of kinetic energy. Dimensions of increase in kinetic energy should be equal to the dimensions of kinetic energy. So it is half mv square, dimensions of kinetic energy. Right, look at board. Stop writing. Look at board. Half is the numbers. Numbers do not have dimensions. To say no dimensions, I just write 1. Capital M is mass, velocity is LT minus 1, but we should get the square. V square, LT minus 1 square. So you get the equation in the form of M square of LL square, square of T minus 1 is T minus 2. Now you see that work done and increase in kinetic energy, both of them have the same dimensions, ml square T minus 1. So finally I can write work done and increase in kinetic energy, both of them have the same dimensions. That dimension is ml square T minus 1, ml square T minus 2. So therefore the equation is dimensionally correct. Therefore, the equation is dimensionally correct. You should write like this to earn full marks. You should write like this to earn full marks. Complete it. Write them all. Right. The second thing that can be done with dimensions, we can obtain some equations by using dimensional analysis. So that is the third and last example that I'm going to give. After I discuss the third example, I'll start discussing mechanics equations. Right. Please write example number 3. Example number 3. When an object is immersed in a liquid, example number 3, please write. When an object is immersed in a liquid, example number 3, please write. When an object is immersed in a liquid, comma, a force is given by the liquid on the object. A force is given by the liquid on the object. A force is given by the liquid on the object. Full stop. That force is known as upthrust. That force is known as upthrust. That force is known as upthrust. When an object is immersed in a liquid, comma, the liquid gives a force on the object. That force is known as the upthrust. Full stop. The upthrust may depend on volume of the displaced liquid. Upthrust may depend on volume of the displaced liquid. Volume of the displaced liquid, comma, volume of the displaced liquid, comma, density of the liquid, volume of the displaced liquid, comma, density of the liquid, density of the liquid, density of the liquid, density of the liquid, and density of the liquid and gravitation acceleration. Density of the liquid and gravitation acceleration. And gravitation acceleration. Gravitation acceleration. Full stop. Use dimensional analysis. Use dimensional analysis. Use dimensional analysis to obtain an equation for the upthrust. Use dimensional analysis to obtain an equation for the upthrust. Use dimensional analysis to obtain an equation for the upthrust. Okay, dear? Use dimensional analysis to obtain an equation for the upthrust. Right? Look at board, dear. Please don't write anything, just look at board. Please don't write anything, just look at board. Right. It is given that, look at board. It is given that when an object is immersed in a liquid, it pushes the liquid away. We know it. How to prove it? How to prove that objects pushes the liquids away? Look at board. Let's say there is a vessel like this. There is a vessel like this. And let's say a tube is connected to this vessel. A tube is connected to this vessel like this. Let's say there is a liquid in it. Maybe water, maybe petrol, diesel, something. A liquid is there. Right? Let's say another vessel is kept just below the tube. What will happen? Look at board. What will happen if I immerse an object in the liquid? Let's say I take a metal ball. Right? I connect the metal ball to a string and I immerse the metal ball in the liquid. Then what will happen? If the volume of the metal ball is 10 cubic centimeter, if the volume of this metal ball is 10 cubic centimeter, 10 cubic centimeter of liquid will be displaced. 10 cubic centimeter of liquid will be displaced. So therefore, when an object is immersed in a vessel, in a liquid, the object pushes some liquid away to get some space for the object. The object takes the space of the liquid and liquid is pushed away by the object. This liquid is said to be the displaced liquid. This liquid is said to be the displaced liquid. So question tells us upthrust. Upthrust means the force given by the liquid. Normally we use the capital R. The liquid gives a force to the object. The upthrust depends on the volume of the displaced liquid. And you know density of the liquid, you know what the density is, and gravitation acceleration of the object. Gravitation acceleration of the earth. So first of all, please write upthrust depend on these three things. Volume of the displaced liquid, let me take the letter V. Density of the liquid, let me take the letter rho. Gravitation acceleration, let me take simple G. For the upthrust, let me use capital R. So first of all, please write these things down. Please write them before you obtain the equation. Before you obtain the equation, write the things exactly like this, exactly the way that I have written. Please, everybody. These questions are not given in the printed as a printed tutorial here. I'm just giving questions. Students write the question and write the answers. I have not given a printed material because it's difficult to give printed material for the online students. The best thing is I'll read the question, you write the question, and let's discuss. That's it. It is not a must to draw this figure here. It's not a must to draw this figure. If you want, you can draw. So this is said to be the displaced liquid. It is not a must to draw this figure. I just use this figure to explain the story. Once the object immersed in the liquid, some liquid is pushed away by the object. That liquid is said to be the displaced liquid. That's it. So this is an object. This is the force given by the liquid. The force given by a liquid is said to be the upthrust. That's it. Right. So what is the method for this here? Sometimes you may have forgotten. Therefore, I would like to give you a small support. Right. So normally we write upthrust proportional. Upthrust directly proportional. Don't write anything. Just look at board. Upthrust proportional to volume to power A. A is a number. We don't know what the A is. A is a number. We don't know what the A is. Actually, the dimensional analysis, the main thing that we are going to do in dimensional analysis, we are trying to find this value of A. In dimensional analysis, we are going to find the value of simple A. Similarly, upthrust depends on the density. So we are going to find dimensions, density to power B. So it means finding ABC is the main thing, right? And upthrust depend on the gravitation acceleration simple G. We write it as simple G to power C. Please don't write. Please don't write. I'll give you the time. So how do we convert a directly proportional mark into an equation mark? Somebody must unmute the mic and tell me how to convert a directly proportional mark into an equation mark. Somebody please tell me.
Multiplied by the constant.
Very good. Who said it? What's your name, dear?
Huda.
Very good, Huda. Excellent. Multiply by a constant. Let's multiply this side by a constant. K. K is a constant into V to power A, rho to power B, and G to power C. And this constant should be a special constant. Then only we can use dimensional analysis. This constant should be a special constant. then only we can use dimensional analysis. The specialty is this constant does not have dimensions. This constant does not have dimensions. We say K is a dimensionless. K is a dimensionless constant. Dimensionless constant. After that, as usual, we write dimension of this side. If this is, don't write, I'll give it time, don't write. If this is the correct equation, dimensions of the terms at the right hand side must be equal to the dimensions of the terms at the left hand side. If this is the correct equation. So then dimensions of R should be equal to dimensions of upthrust should be equal to dimensions of K, dimensions of V to power A, dimensions of rho to power B, and dimensions of gravitation acceleration to the power C. I think you can do the rest and find ABC. Find ABC, take a photo and send to my WhatsApp. I'll check your answers personally. Therefore, write them all, find the ABC constants, take a photo and send my WhatsApp. Start here. Everybody please try. Somebody please please type the question and send to WhatsApp. Is it possible? Somebody please help, because some students say that they didn't hear the question properly. Please help others. Somebody please type the question and send to my Zoom chat. Capital R is the force. Capital R is the force given by the liquid to the object. Capital R is the force given by the liquid to the object, which is said to be upthrust. Capital R is said to be upthrust. So we are going to obtain an equation for the upthrust with the terms volume of the displaced liquid, density of the liquid, and gravitation acceleration. I have written those things right hand side of the board. Thank you, Jeremy. Thank you very much. I'll share the question with the other students. You did a very big help for all the students. And if somebody was not able to write the question, please read the Zoom chat. The question is sent to the chat. Right. Let me show you a few steps, some more steps. So it is said that upthrust depends on volume of the displaced liquid V, density of the liquid rho, and gravitation acceleration. So if this equation is dimensionally correct, dimensions of this side should be equal dimensions of all the terms at the other side. Upthrust is a force. Upthrust is a force. Therefore, dimensions of upthrust should be equal to the dimensions of force mLT minus 2. K is a dimension constant, therefore no dimension L to power 3, but we have another power symbol A. Rho is the density. We have found the dimensions of density, that is ml minus 3. Dimensions of density ml minus 3 to the power B. Simple G, gravitation, acceleration. Gravitation or whatever, acceleration is acceleration. Therefore, dimensions of acceleration is LT to power minus 2 to the power C. Check whether you have written this step there. Everybody please check whether you have written this step. Who has written this step? Please raise your hand up in the Zoom chat. Very good, excellent. So it means all of you have written this step. The final thing is just remove the brackets. Remove the brackets. If you have written this step, let's remove the brackets, right? So m LT minus 2 L to power 3, everything to power A. It means L to power 3A. This B is a power of M as well as this B is a power of L. So it should be M to power B, L to power minus 3B, L to power minus 3B. Similarly, this C is a power to L as well as C is a power to minus 2. So it is L to power C and T to power minus 2C, T to power minus 2C, right? So then finally, stop, please wait until I write. M can be written as M to power 1, L to power 1, T to power minus 2, T to power minus 2. Now look at both. Stop writing, please stop writing. Now how many M terms are there? Only one M term is here. That is M to power B. Only one M term is there. M to power B. How many L terms are there? Stop writing. How many L terms are there? L to power 3A, L to power minus 3B, L to power C. 3 terms are there. So finally, we should write L to power 3A minus 3B plus C. That's it. L to power 3A, L to power minus 3B, L to power plus C. And how many T terms are there? How many T terms? Only one T term is there. That is T to power minus 2C. Please write them all. And who has already written them all? Please raise your hand now. Who has already written all these things? Very good. Excellent. Right. Others, please quickly write. Others, please quickly write these things. Right. So finally, let's equate the powers. Finally, let's equate the powers. I think this is very simple for you. If you look at board now, I have given you time, so you should listen to me now. Here, m to power 1, this side m to power p. So it means if I consider the power of m, right hand side, the power of m is 1. Sorry, left hand side power of m is 1. Right hand side power of m is b. If m and m equal, their power should also be equal. M and m equal, power should also be equal. So m to power 1 left hand side, m to power b right hand side, therefore b equals 1. Who got this answer? Lamai, who got this answer? Right, very good, nice. Then what about t? If you consider the power of t, here the power of t is -2. Here the power of t is -2. The other side power of t is -2c. So if you consider the power of t, this side -2, the other side -2c. Let me take -2 to this side. -2 divided by -2 equals c. Therefore, c equals minus to minus cancelled out. 2 divided by 2 is 1. So c equals 1. That's it. Who got this? Who got this answer also? C equals 1. Wow. That's so good. Nice. Excellent. Superb. Very good. Very good. Right. And final thing, I would like, if you try for the final thing is the power of L. The final thing is the power of L. This side power of L is 1. My left hand side power of L is 1. My right hand side power of L is 3a minus 3b plus c. Can you do the rest and find the value of simple length? Right, simplify, find the value of simple length. Right here, everybody please try. Right. I think time is enough. Even many students send me the answer to my Zoom chat. I'm very happy. Your students should be active, should not be sleeping, right? So this 2 years is the most important time duration in your life. So at night you have to work. Daytime you have to work. In the morning you have to work. So all the 2 years you have to work to obtain a very good result, right? Look at board here. So L, the power of L is, I have written this by considering the power of L. 1 equal, I don't know the value of A, but I know the value of B. B is 1, 3, B is 1, C is 1, C is also 1. So then 1 equal 3A, 3 into 1, 3 plus 1. I'll do something like this. I'll take -3 to this side. I'll take this -3 to this side. 1 Minus 3 come to this side as plus 3. Plus 1 come to this side as minus 1 equals 3a. Can you understand this maths here? Can you understand this maths? I have taken minus 3 to this side, so it becomes plus 3. I have taken plus 1 to this side, it has become minus 1. Now what will happen? This plus 1 and minus 1 cancelled out, only 3 will be there. So 3 equals 3a. If you take this 3 to this side, 3 divided by 3. What is 3 divided by 3? 3 divided by 3 is 1. If you take this 3 to this side, 3 divided by 3 equals a. It means a equals 3 divided by 3 is 1. So it means a is also 1. A is also 1. Who got this answer? Please raise your hand up in the Zoom chat. Lamai. Very good. Excellent. I'm so happy. So it means you have understood the dimensional analysis lesson very well. You have nicely understood dimensional analysis. Excellent. Good. Write them all quickly here. Everybody, if somebody was not able to obtain the answer, please write this note quick. Right. Finally, we should write one more step to earn full marks. We should write one more step to earn full marks. That is the equation. So what is the final equation there? That's the final equation. R equals a constant into v to power a, rho to power b, and g to power c. That's what we have. This is how we started. So k into v to power a is 1. We have found a as 1. Rho to power b, we have found b is 1. G to power c, we have found c is 1. 1, 1, 1, all the things. Therefore, the upthrust is equal to k v rho g. Actually, this is Archimedes' principle. Upthrust equals v rho g. It means the value of the constant k is 1. Value of the constant k is 1. So upthrust equals v rho g. We can, if by doing a simple experiment, we can prove that k is 1. So it means we have proved that Archimedes is true. Archimedes is correct. We have proved it by using dimensional analysis. Please write them all. After that, let's start to discuss some mechanics questions. Start here. Right. So I have used a lot of time for the dimensional analysis because I explained the theory also. Because there may be some new students, there may be some student who has not learned this theory properly. That's why I discussed the theory. But for the mechanics question, I'm not going to explain the theory much. I just write the equations of linear motion and I'm going to discuss some good questions, right? At least I'll try to discuss 2-3 questions. For this tutorial discussion class, please use a separate book. And normally, you should write the questions and write the answers. Therefore, it's better to keep a separate book If you use papers to write, it means some student may be using photocopy papers or foolscap papers, then please keep a file for it and write the date properly. Date of the class and write the question and write the answers. Keep the papers inside the file if you use papers. But the best thing is using a book and do use one book and write all the questions. You write the date, write the question and write all the things in a single book for this tutorial discussion class. And same time, I will be discussing some papers also. I'm going to discuss papers also in near future. Right? In mechanics, we have started with displacement. Displacement is said to be the shortest distance between any 2 points. Displacement is measured in meters. Velocity is the rate of change of displacement measured in meter per second. Acceleration is the rate of change of velocity measured in meter per square seconds. Then we have obtained something so called equations of linear motion. To obtain the equations of linear motion, we have considered an object. We have considered an object which is moving with a constant acceleration. Initial velocity is u meter per second. After t seconds, after some time, the velocity of the object is v meter per second. Right? The time taken for the object to increase the velocity from u meter per second to v meter per second is t seconds. The displacement of the object during the t seconds is s meter. Acceleration of the object is a meter per square seconds. Acceleration of the object is a meter per square seconds. The four linear motion equations are v equals u plus at. The second equation is s over t equals u plus v over 2. The third equation is s equals ut plus half at square. The fourth equation is v square equal u square plus 2a s. No need to write these things, everybody knows. I just written them. If there's anybody who has not learned, and if there's anybody in the class who has not learned how to prove these equations, if there's anybody in the class, if you have not learned how to prove the equations, please send me a WhatsApp message. I'll send you the recordings how to prove the equations. It's very important to know how to prove. In the exam years, they don't ask you to prove the equations. Yes, they don't ask. But it's very important to know how to prove the equations. Therefore, please send me a WhatsApp message if you are not in my class when I was teaching these things. Right. Now write the example. Question. Example. An object is moving along a straight line path. An object is moving along a straight line path. An object is moving along a straight line path as shown in the following figure. Please draw the figure quickly, dear. An object is moving along a straight line path as shown in the following figure. Draw this figure here, quick. Please quickly draw this figure and wait until I give you the questions. Draw the figure and wait until I give you the questions. Let me name the starting point as A, this point as B, this is C, and this is D. A to B displacement. Let me take A to B displacement as 100 meter. I don't know the time. I don't give you the time. B to C displacement. Let me take B to C displacement as 200 meter. I don't give you the time. And C to D displacement. C to D displacement. Let me take S3 as 300 meter, and I do not give you the time. Draw the figure and please wait until I give you the questions. Start. Please send a message if you have drawn the figure completely. Please send a message to the Zoom chat saying done. So then I know that you have done it. Right. Anybody wants any more time to draw the figure? If anybody wants any more time to draw the figure, please raise your hand up in the Zoom chat. No need, right? So I will not erase the figure. Please write the question. I will not erase the figure. Please write the question. The object travels from A to B. The object travels from A to B with a constant velocity of 5 meters per second. The object travels from A to B with a constant velocity of 5 meters per second. 5 meters per second. The object travels from A to B with a constant velocity of 5 meters per second. Full stop. The object travels from B to C with a constant velocity of 10 meters per second. Full stop and write. The object travels from B to C with a constant velocity of 10 meters per second. 10 meters per second. The object travels from B to C with a constant velocity of 10 meters per second. Full stop. Finally, full stop. Finally, the object travels from C to D. The object travels from C to D. The object travels from C to D. The object travels from C to D with a constant velocity of 15 meters per second. The object travels from C to D with a constant velocity of 15 meters per second. Full stop. The question is, find the average velocity of the entire motion. Find the average velocity of the entire motion. Right here. Try to find the average velocity of the entire motion. Take a photo and send to my WhatsApp. I'm waiting for your answers. Find the average velocity of the entire motion. Try to obtain answer yourself. Take a photo of your answer and send to my WhatsApp. Quick. So the thing is, you want to find the average velocity of this motion. I'll give you a small help there. Objects moving with constant velocities. What is the velocity of the object from A to B? 5 meter per second. Velocity of the object from B to C? 10 meter per second. It means at the point B, velocity change from 5 to 10 and then it travels with the velocity of 10. At the point C, velocity change from 10 to 15, then it travels with the velocity of 15 meter per second from C to D. That's it, right? So if objects are moving with constant velocities, no need to use any of these equations. That's the magic. So look at board here. As the object is moving, with constant velocities, the following equation can be applied, right? Can somebody unmute the mic and tell me the equation that can be applied for a constant velocity? Somebody in the class, Lamai?
Velocity equals displacement over time.
Very good, excellent. What's your name here?
Aruni.
Very good, Aruni, excellent. If something is moving with a constant velocity, no change in velocity, therefore we can use the equation velocity equal displacement divided by time. Velocity equals displacement. Please don't write. Velocity equals displacement divided by time. For the velocity, let me use the letter V. For the displacement, let me use the letter S. Divide by T. So the thing that I'm going to do is I'm going to interchange the terms S and T. So I can obtain an expression for T. T equals S. T comes here, V equals there. That is T equals S over V. So this is what you want to obtain first of all. Even you can use the equation S over T equal U plus V over 2 or S equal UT plus half A square equation for this question, but this is the easiest method. So I would like if you all write this equation and try to find T1, T2, T3. Try to find T1, T2, T3. Right here. If you have obtained T1, T2, T3 values, please send the values to Zoom chat here. If you have obtained T1, T2, T3 values, send the values to Zoom chat. Right, excellent. Actually, majority of the students, I thought that nobody will answer, but majority of the students answer the question. So it means next week I'll give you more difficult question than this. Students don't care this question, right? Almost all the students got the answer. I'm very happy, right? When once I just say send me the values of T1, T2, T3, all the students send me, right? You can go here. It's nothing. So I thought that nobody will. I thought that students, not all the students got the answer, but yes, yeah. So okay. Majority got the answer. So I'll finish this question. Look at board. So A to B. Let me apply the equation. T equal S over V. In AB section, displacement is 100 meter, time is T1. In AB section, time is T1, displacement is 100 meter, velocity in A to B velocity is 5 meter per second. So therefore T1 is 100 divided by 5 is 20, unit is seconds. Who got this answer? I would like to check again. Who got this answer? Please raise your hand up in the Zoom chat. That's it. Okay. Right, good. Everybody knows physics. That's it. So next week I'll give you more difficult question than this, right? Please be well prepared, right? So T1 is this. Good, right? The second thing, BC section. B to C. Let me apply the equation. T equals S over V. Time from B to C time is T2, B to C displacement 200 meter, velocity, B to C velocity is 10 meter per second, Therefore, T2 is 0 cancelled out, 20 seconds. It means T1, T2 both are equal. What about T3 here? T3 can be obtained from CD section, C to D. I apply the equation T equals S over V. In CD section, time is T3, displacement is 300 meter, and the time, velocity. CD displacement 300 times T3, the velocity is 15 meter per second. Therefore, T3 is 30 divided by 15 is 20 seconds. So it means T1, T2, T3, all are 20 seconds each. T1, T2, T3, 20 seconds each. So almost all the students got the answer, but even a single student is there, he or she can write these answers. Quick. Right. So what is average velocity? Right? What is average velocity? Can somebody unmute the mic and tell me the equation that we used to find average velocity? Anyone in the class?
Total displacement or total time taken.
Very good, excellent. What's your name, dear?
Netme.
Very good, Netme. So the average velocity is total displacement divided by total time taken. Very good. So next week, definitely promise I'll give you more difficult question than this. Be well prepared, right? So then average velocity equals total displacement divided by total time taken. Total displacement divided by total time taken. So total displacement means S1 plus S2 plus S3. Total time means T1 plus T2 plus T3. Shall we do it? Total displacement S1 plus S2 plus S3. S1 plus S2 plus S3. Total time is T1 plus T2 plus T3. Can you do the rest and find the average velocity here? Now I try to find the average velocity. Everybody. So S1 is 100 meter. S2 is 200 meter. S3 is 300 meter divided by T1, T2, T3, 20, 20, 20, 20, 20, 20. So therefore, 300 plus 200, 500 plus 100, 600 divided by 20, 20, 20 means 60. 600 divided by 60 is 10. 10 meter per second is the average velocity. Who got this answer, Lamai? Very good. Very good. Right. Now I'm going to give you another question. I'm going to give you another question. First, please quickly complete this one. After that, I'll give you another question. Right. I'm going to slightly modify this question. I'm going to slightly modify this question. Look at board. Let's say S1 is D meter. S2 is also D meter. I'm going to do a small change. S3 is also D meter. So an object is moving along a straight line path like this. A to B displacement D meter, B to C displacement D meter, C to D displacement is also D meter. And object travels from A to B with a velocity of U meter per second. And object travels from B to C with a constant velocity of V meter per second. And the object travels from C to D with a constant velocity of W meter per second. So this is your next question. You want to find average velocity. Please write. I will not erase any of these things. Promise, I will not erase any of these things. Put the next question number and write. Next question number and write. An object travels along a straight line path. An object travels along a straight line path with constant velocities. Next example, an object travels along a straight line path with constant velocities, as shown in the following figure. An object travels along a straight line path with constant velocities as shown in the following figure. Full stop. Obtain an expression for the average velocity of the object. Obtain an expression for the average velocity of the object. Obtain an expression for the average velocity of the object. Average velocity of the object. Draw the figure here. Draw the figure. So it means as in the previous question, object travels from A to B with a constant velocity of u meter per second. Object travels similarly. Object travels from C to D with the constant velocity of w meter per second. A to B velocity is constant u meter per second. B to C velocity is constant v meter per second. C to D velocity is constant, that is w meter per second. And AB displacement d meter, B to C displacement d meter, C to D displacement is also d meter. Now, if you have drawn the figure, you try to obtain an expression for the average velocity. So, 2 hours is more than enough as a beginning. This is the first day that we discussed the tutorial discussion class, and I'm going to convert this class into a paper class, paper and tutorial discussion class. But at the beginning, 2 hours more than enough. So, you try to answer this question at home. Solve this problem at home. Take the clear photos of your answers and send to my WhatsApp. Okay, dear? So what should you do? Consider this as a homework. Answer this question at home. Take the photo of your answers and send to my WhatsApp. Right? So I think that's enough for today. See you next week. Good luck. Bye. Take care.